Dear ladies and gentlemen, I'm Beata Jarosjevic, a teacher at Denis Gabor College from Budapest, Hungary. As college professor, I teach physics and computer science in distance learning and full-time education. Besides my job as part-time work, I teach for computing for primary and secondary students from SEK, Budapest International School. Therefore, I am involved in education from age 6 up to 99. In the next few minutes, I will talk about modern physics teaching resources and activities. The main part of my talk is focused on teaching methods used during physics education. I will also show you my e-learning courses prepared for students and different methods for the implementation used of these courses. Analyzing the results of my previous research activity and compare with other researchers' results, we were confident, and I am confident, that the attitude of the students has been changed immediately as soon as possible, and we should react somehow to change their attitude to make physics classes more colorful, attractive, and interactive. But the main question is always how. What we can do to make these courses more understandable. In the following concept map that is presented, you can see some examples of activity which I use during my physics classes to make physics more interactive with the help of the simulation or with the games, and using brainstormings via using different tools like tablets and mobile devices. Aim of the used activity is very important, which can contribute to improve our students' researching, critical thinking, problem solving, and computational competencies. In use of the activities is not enough, as I said before. We need to use also the new technologies, portable devices, mobile phone, tablets. It is very important that physics cannot be taught without experiments, but not every experiment can be solved or can be presented for the students. We don't have the example equipment, or we cannot use radioactive materials. In these cases, we should use the multimedia and ICT and its application. Without the computers, physics cannot be taught nowadays. This concept map I would like to present for looking to the ICT importance and how ICT can be used in different ways in physics education to create presentation, but not only presentation, to use for surveys, to use for evaluation and real measurements which can be done via ICT and different computer softwares. Here you can see that ICT improve students' learning, researching this key question. I found that teachers can use better methods for knowledge comprehension, practical skill, and presentation skill improvement. These are different categories which are very important nowadays in our educational activities. Possibility for use of ICT in education is very different. How to use the ICT, that's the main question. In every classes, or when? In each classes, in the beginning of the class. Do we know the real methods that we will use, or do we know enough? These are main questions that has to rise up in teachers' mind. We can sometimes create e-learning materials which are calm materials for students, but we should use the e-learning devices like free software for assessment, Quizlet or Socrative, or other different questionnaires to answer the questions. And of course, teaching methods are very important. It's not enough only the devices. The teaching method refers to general principles, pedagogy, and management strategies. The main teachers methods are really divided into two categories, like teacher-centered and student-centered. It depends on the education philosophy of the classroom demography. Every teacher can choose which strategy, which teaching method we will or she will use during the education. If you turn to the methods, you will see that in my courses, lecture method, cooperative method, and inquiry-based method can be used for implementation of the e-learning course. One of the methods used is for describing the structure of atoms, the concept of atomic mass or mass number, or jigsaw method can be used in collaborative work. Students can be split in groups, and work group activity and their assessment can be based by gamification. In this case, students get coins, they can randomly drop the coins and finally plot the exponential curve. Or inquiry-based learning, you will see using the simulation embedded in the ICT course. These can be implemented by the teachers. Of course, the target of the course are students and teachers. These courses can be used by teachers and by individual learners, students, even from high school and from BSc level. You will see that learning objects can be used also separately. The first course is the exponential decay law. The aim of the course is to teach some fundamentals property of the radioactivity, random behavior, exponential decay law, and to be familiar with the half-life, how you calculate the decay constant and activity. In this link, you can reach my course, which is available online for free. And now I will turn to a nice screen capture made about the course to show you that the course has an introduction part which can be used frontal, and you have multiple choice question which can be answered by students. You can get the hint to the correct and wrong answer, and finally you can turn to back to the main menu. Here you will see the simulation of radioactive decay. There are some explications describing cause that blue circle represent the radioactive nuclei, and the red circle the decay products. Students can decrease and change the decay probability. Therefore, this simulation is very interactive. And here, if you click, you can see in the main screen, the single step and continuous step, the simulation program and the decay probability. Students can make also calculations, and they can get the feedback answer to their questions if they reach the students or if they reach the teacher's corner built in the course. Finally, they have an exercise for the age determination based of radioactive nuclei. This is a more theoretical calculation. For this, they need to turn to glossary and look to the formula. And finally, they have useful links which can be reached by the students. Next course is radioactivity that I created. The aim of the course is to teach changes in the nuclear composition during the different decay modes like alpha, beta, and gamma decay, and to teach the fundamental notion, atomic mass number, and what does it mean, isotope, where we will find isotopes. If we turn to the course, you will see that the composition is very similar. You can see the introduction part, the composition of nuclei. There are multiple choice questions built in the course, and the same right and bad answer can we get clicking to the right and the wrong answer. We have a menu and we can turn to radioactive nuclei, radioactive radiation, and we find what is the differences between alpha, beta, and gamma decay. And you can see with this little animation the changes of the atomic number and mass number. Negative beta decay will also explain as the electron emission, and gamma decay, the nucleus emits electromagnetic waves. And of course, you can turn back to the multiple choice question as feedback when we already learn about the alpha beta decays. Finally, here we have also glossary, and we have the formulas that can be used later on, and we have useful links. One of the useful links I collected to show you that this link has an app which can be downloaded for tablets and can be used even by tabs and mobile phones. You can see the penetration of the alpha and beta particle through the paper, aluminium, and plumb. Finally, I would say that teachers who already use some of the courses and methods presented before give me a very positive feedback. Their students were very motivated and enthusiastic. I hope that these learning objects can be used very well in modern physics teaching and education, and we can make the hard sciences more attractive and understandable to more students. Finally, I would like to offer my thanks to my husband, Csaba Süköst, physicist, who contribute to make this simulation, which are embedded in this course. As you see, more reference I have been used, and I would like to thank for your attention with a quotation made by Denis Gabor: "The future cannot be predicted, but futures can be invented." Thank you for your attention.